Electron affinity. Electron affinity is kind of like the opposite of ionization energy. It's the energy change when a neutral atom gains an electron. And these are usually negative, meaning exothermic, but sometimes they're positive. So here we're taking a neutral atom, we're adding an electron, and usually that results in energy being given off. Then we have a negative ion. Some alkaline earth metals and all noble gases have positive electron affinities. Why would a noble gas have a positive electron affinity? So noble gas going to be real happy about getting an extra electron. Like, you're screwing up my look, right? It's just totally coordinated head to toe, perfect, and then you're making me wear this green hat? It's just messing everything up, right? It's throwing a wrench into the works. Alkaline earth metals. Why would they be particularly upset? Where are the alkaline earth metals? Group 2A, right? So group 2A, where's the next electron going to go? It's going to go in the d orbital, most likely, right? So that's not going to be good. That's going to just kind of mess things up. The trends that we see in electron affinity are less regular than the other trends. Generally, they're going to decrease, become more positive, less negative. That gets confusing. As we go down in group 1A, the other groups don't really show a trend. It's just kind of a wash. We do see that it generally increases, becoming more negative as we go across a period. And in general, that makes sense because who's going to be the most enthusiastic about getting an electron? Group 7A, right? Because they just need that one electron, they get the noble gas configuration, the 8 valence electrons, the cool factor. So that's going to have the most negative. Sorry about the negative positive thing. But it's going to release the most energy when the electron is added. It's going to happen the most easily. Then there's a little glitch in group 5A. It's not as high as we expect because that electron that goes in has to pair up. And so that's that nitrogen. Nitrogen in group 5A, it's got 3 electrons in the p orbital. It's half full. You throw one more in there, and it's got to pair up with another electron. So it's still negative, it's still exothermic, but it's just not as exothermic as we would expect. And of course, the highest electron affinity in any period is going to be the halogen. They are just not going to want to take an extra electron. So here's the table showing electron affinities. And as you can see, these guys, there's a trend, but here, going down in these other groups, it's not so much. It's kind of random-like. But we do see a trend as we're going across this way. It's not fabulous. Properties of metals and nonmetals, you can read, right? Malleable means you can hammer it into a sheet. Ductile means you can pull it into a wire. You can do that with metals. Nonmetals, not so much. They tend to be very brittle. They'll just shatter. Shiny versus dull, conducts heat and electricity, don't conduct heat and electricity. Most of the oxides are basic versus most of the oxides are acidic. Forms cations, forms anions, loses electrons, gains electrons. They're just kind of opposites. And so that's part of why I think of the metals as being masculine and the nonmetals as being feminine. Because, I mean, they're all elements, they're all atoms, but they just have these general characteristics. You know, do all women like to cook? No. It's not an absolutely uniform thing. Are all nonmetals brittle? Well, not necessarily. But generally, these things are true. So there are trends in metallic character. Metallic character means how metal-like is this element. So yeah, there's that. I think, yeah, here's a table. So this one I think is the easiest to remember. Okay, so if you're going across a period, over here, are these metals or nonmetals? Those are metals, and over here these are nonmetals. So maybe going from metals to nonmetals, metallic character is decreasing, right? So we're going across. And up and down, here's nonmetal, metal, metallic character is increasing as we go this way. So that shouldn't be too hard. Yeah, and there's a better periodic table showing the metals and the nonmetals, and so you remember the stair-step line separates metals and nonmetals. You can figure that one out pretty quickly. Oh, I don't want to do that. You can figure it out.